When we left off last Wednesday, we had this graphing worksheet to work on, where I'd asked you to fill in, we did a couple of these together, and I'd asked you to fill in the rest of the graphs. So I want to start off just by going through and sketching each of these graphs. So for the first one here, y equals 3x minus 2. So you get a straight line, something like that. For number 2, y equals 6 minus x. We're going to end up with a line like that. So the first two are lines. The next one here is not. Y equals x squared plus 2x plus 1. It's going to look like that. Remember we discussed this? That is called a parabola. Now this next one is one that we actually did together in class. Looks like this. And remember, this one has an arrow on one end of it, but not on this end. And then we discussed that that was because if x is less than negative 6, what's inside that square root would be negative, and we cannot take the square root of a negative number. So x cannot be less than negative 6, which means that we kind of have an invisible line here that we can't cross. We cannot go to the left side of that line. And that's a limiting factor on this graph. If this were a more formal algebra class rather than just a small algebra unit within this course, we would talk about domain restrictions and stuff like that. So any questions on those first four? Is anybody getting majorly different and not sure why? Okay. So this next one, number 5, is a pretty straightforward. Y equals 3 plus 3x. It's going to look like that. So that one's a line as well. 6 is a little bit trickier. Y equals 2 to the power of x. Is going to look like that. Now this is another one that has a limiting factor to it. And in this one, it's just this independent or x-axis. That graph is going to get closer and closer to that as we go to the left here and further into the negatives, but it'll never quite touch it. Y will never quite equal 0. It'll get smaller and smaller and smaller, but never equal 0. In this case, since the graph is approaching a line, getting closer and closer, but never touching it or never crossing it, that's something we call an asymptote. That's all an asymptote is a line that the graph will approach but can never touch or never cross. Number 7. Y equals x to the third minus 1. This is going to look like this. Kind of an S shape, sort of. Number 8 can be really tricky here. So I'm going to plot out the points and kind of talk through this one. If x is negative 8, y would be 8 divided by negative 8, which is negative 1. So we've got negative 8, negative 1 is that point right there. If x is negative 4, y is 8 over negative 4, which is negative 2. So we've got negative 4, negative 2. If x is negative 1, y is 8 over negative 1, or negative 8. So negative 1, negative 8 is right there. If x is 1, y is 8 divided by 1, or 8. So we've got 1, positive 8. X is 2, y is 8 divided by 2, or 4. So we've got 2, 4 is right there. If x is 8, y is 8 divided by 8, which is 1. So we've got 8, 1 right there. Some points I would fill in that aren't on here. I would say if x is negative 2, y is 8 over negative 2, which is negative 4. So negative 2, negative 4 is right there. Or if x is 4, y would be 8 over 4 or 2, so x would be 4, y is 2 is right there. Now looking at this, we look like we have a distinct curve over here on the right and on the left, but how do we get from this point to this point? And the answer is we don't. If we let x equal 0, y would be 8 over 0, and if we punch that into our calculator, it's going to tell us error. It's not going to allow us to do it. One of the big things in math is we cannot divide by 0. And that's actually a very hard and fast rule. A lot of really weird things could happen if we allowed it to happen. So x can never be 0 here. So that is considered another asymptote. This graph will get closer and closer to that line, but it'll never get to where x is 0. So this ends up being two separate curves. We have a curve on the left side here that gets closer and closer to 0 there. Actually, it's closer and closer to the x-axis here, 0 on that side as well. And the same here. Gets closer and closer to 0 there and on this side. So we have that y-axis, that x equals 0 asymptote. We also have an asymptote on the x-axis at y equals 0. That'll never actually cross. I'm going to graph these last two, and I'm going to come back to that notion of not being able to divide by 0 and show you how important that is. Okay, next, y equals 4x squared minus 8 is going to look something like this. So again, that's another parabola. And finally, y equals 3/4 x minus 4 is going to look something like this. So that is a line as well. Now we're going to come back and we're going to talk a little bit more about these graphs in a second. But I want to address that whole issue of dividing by 0 and why that is so important. If we are allowed to divide by 0, some really funny things can happen. And one of the best demonstrations of that I can think of right now offhand is a simple little equation exercise. I don't think I showed this one to you guys earlier. Stop me if I did. But if I let x equal 1 is a simple equation. Now we know that there are a lot of things from what we've seen before in algebra. There's a lot of things we can do with that equation. One of them is I can multiply both sides by the same thing. So I'm going to multiply both sides of this by x. X times x is x squared. 1 times x is just x. So that's just fine right there. 1 squared is 1 equals 1. So we're still fine. The other thing we can do is we can subtract the same thing from both sides of an equation. So I'm going to subtract 1 from both sides. So x squared minus 1 is just x squared minus 1. X minus 1 is just x minus 1. Well, it still works out just fine because 1 squared is 1 minus 1 is 0. 1 minus 1 is 0. We're still looking good. So now we're going to look at this. The x minus 1 we're going to leave. X squared minus 1 we're going to split up. If I did x plus 1 times x minus 1, if I multiply that out, x times x is x squared. X times negative 1 is negative x. 1 times x is positive x. 1 times negative 1 is negative 1. When I combine things here, I've got the x squared. Negative x and positive x cancel out, make 0, and I've got minus 1. So x squared minus 1 is equivalent to x plus 1 times x minus 1. And that's perfectly legal. I can split that apart like that. So now what I'm going to do is this. I'm going to divide each side by x minus 1. So the x minus 1 there cancels out, and it cancels out over here. When I divide out, when anything divided by itself is 1, so that's 1. The x minus 1 divided out here, so I'm left with just the x plus 1. And my final step, I'm going to subtract 1 from both sides. So that 1 cancels out. I get x equals 1 minus 1 is 0. X equals 0. But I started out with x equals 1. So what I just proved here is if x can equal 1 and x can equal 0 at the same time, that's telling me that 1 must equal 0. Well, we know that cannot be true. At least we hope it doesn't. Otherwise, most of what we've learned in math is totally unusable. Well, the problem with this, does anybody see the problem with what I just did here, by the way? It comes right here. I divided by x minus 1. But remember, we started out x equals 1. So x minus 1 is 1 minus 1, or 0. So what happened in this step here is I divided by 0. And when we divide, if we allow ourselves to divide by 0, you can see here the whole framework of numbers falls apart. So it's very important that we do not allow ourselves to divide by 0. Okay, back to our graphs. We're looking at these graphs here, and there are 4 of them that make lines. Number 10 here, number 5, and numbers 1 and 2. So those equations make lines on the graph. So what I want to focus on for a minute is the other ones. The ones that do not make lines on the graph, like 3, 4, 6, 7, 8, and 9. Looking at those equations, I have y equals x squared plus 2x. I'm going to list them out over here. X squared plus 2x plus 1. Y equals the square root of x plus 6. Y equals 2 to the x. Y equals x to the third minus 1. Y equals 8 over x. And y equals 4x squared minus 8. So those 6 equations did not form lines on the graph. Ones that did form lines were y equals 3x minus 2, y equals 6 minus x, y equals 3 plus 3x, and y equals 3/4 x minus 4. Should have wrote these a little smaller here. I'm going to go ahead and slide them in together. There, now we can get them all on the same page here. Looking at these equations, I want to compare the ones on the left here that are not lines and the ones on the right that are lines to see what's different. More specifically, what do these equations over here have that these do not, that make them not be lines? Can anybody see anything over here that's different on these equations on the left? I'll point these out. What am I highlighting there? We're looking at powers or exponents on the variable. Now I should say other than 1. Because every number has a power on it. It's just that power is usually 1. This is x to the power of 1. But we don't write it because it's a 1. Included in that, by the way, is this here. The square root is a form of an exponent. If you recall, when we talked about order of operations, exponents included both powers and roots. Well, the second thing, still kind of dealing with exponents, is this equation. In that case, the variable does not have a power on it. In that case, the variable is the power. And then finally, this last one here, y equals 8 over x. You could actually think of that as 8 times x to the power of negative 1. So you think of that as being a power on x other than 1. Well, we'll address that one specifically, as you cannot divide by x. So these three things that I just listed here are all three things that happened in these equations that made them not be lines. And those are three things that I refer to as the three don'ts of linear equations. If an equation has any of those things, it will not be a line. It will not form a line on the graph. It will not be a linear equation. So with those in mind, let's take a look at some equations here. Yes or no? Is that going to make a line or not? Somebody be brave. Yes, it will. It does not have any of our issues. How about this one? Yes or no? Line or not? It's really tempting to say no because you see that 5 to the third power. However, 5 to the third power is just 125. The power only affects us if it's on the variable. So yes, that one will be a line. How about this one? Line or no? No, because of x to the negative 1, that will not be a line. How about this one? It's tempting to say no again, but remember, we can take 7x and 2x, make 9x minus 3. So yes, that will be a line. How about this one? No, because we got 7 divided by x there. That cannot be a line because we divided by x. How about this one? This one's kind of a sneaky way of doing it.
Yes.
Careful. Yeah, if I distribute that through, 5x times 3x is 15x squared. 5x plus 2 is 10x. So it looks like it's okay at first, but if we actually carry it out, it does have a power on the variable. So that is not a line. So it takes a little time to get used to looking at these, but we will be able, you can look at an equation and tell whether it's a line or not just by looking at it. So once we know that it's a line, there has to be a shortcut for graphing it. Now, you saw me graph those equations on the worksheet just by looking at the equation. So there has to be a shortcut for each form. So as we focus in on lines, and let's look at graphing shortcuts. Let's start out with the simplest linear equation I can think of. And that equation would be y equals x. So y equals x, if I go to graph that equation, if x is, let's say x is negative 3, what does y have to be? Well, negative 3, right? Because y equals x. So that gives us a point here, negative 3, negative 3. If x is 0, what's y have to be? 0. Very good. Y equals 0. Y equals x. If x equals 2, what's y have to be? 2. Good. So that gives us a point here at 2, 2. And we can see that all it takes is 3 points to verify that that's a line. Technically, all we need is 2 points to create a line, but I usually do the third one just to verify that it is a line. So that's the simplest form of a linear equation we can come up with, y equals x. Well, there are some things we can do, just like we did with our basic equations a couple of units ago. We can build onto that equation to make it more complex. One thing we can do is add or subtract. So let's add. Let's do y equals x plus 3. So now if that's the case, we've got x and y. If x is negative 4, what's y have to be? Well, what's negative 4 plus 3? Negative 1, perfect. So we got the coordinate negative 4, negative 1 is our ordered pair. If x is negative 1, what's y have to be? 2, good. Negative 1 plus 3 is 2. So we got the point negative 1, 2. If x is positive 1, what's y have to be? 4, good. So we have the point 1, 4. Again, we can see that's a straight line. And if we look at it, it is parallel to that original line. It's just been moved up 3 spots. So adding 3 to the x just moves the line up 3 notches on our graph. So with that in mind, let's think about y equals x minus 2. Without even doing the table, what do you think is going to happen to that line from the original? Perfect. It's going to move down 2 spots. And I could verify it. If x is 0, 0 minus 2 is negative 2. If x is negative 2, negative 2 minus 2 would be negative 4. If x is 3, 3 minus 2 would be 1. So we get that line there. That is still parallel to our original line. It has just moved down 2 spots. So adding or subtracting, take that line and move it up or down. Let's change the angle of the line. And to do that, let's take a look at something like this. Y equals 2 times x. I'm going to multiply the x instead of adding or subtracting. So now, if x is negative 2, what's y have to be? What's 2 times negative 2? Negative 4. Good. So we get the ordered pair negative 2, negative 4. If x is 0, what's y have to be? 0. 2 times 0 is 0. So we're at 0. We're back going through the origin again. And of course, if x is 3, y has to be 6. So we're at 3, 6 will be up here somewhere. So I get that line like that. So y equals 2x. We're back going through the origin again, back through the center of our graph, but we're steeper than the other lines. Well, if multiplying makes it steeper, how would we make it less steep or shallower? Divide. Very good. So we might have y equals x divided by 3. Now in algebra, we don't like dividing variables by numbers. So instead of y equals x divided by 3, I'm going to write it like this. Y equals 1/3 times x. So instead of dividing by 3, we're multiplying by the reciprocal of 3, the 1/3. So here now, if x equals negative 3, what's y have to be? One-third times negative 3 is negative 1. So negative 3, negative 1 is right there. If x is 0, what's y have to be? 0. Good. Right there is 0. And if x is 6, what's y have to be? 2. Good. So right there. So you can see we do, in fact, get a line that still goes through the origin, but it's less steep. It's a shallower angle. So far, all of the lines we have graphed, as we move from left to right on our graph, go up. What would we have to do to make a line go down, do you think? Multiply by a negative. Exactly. So y equals negative 2x. If I graph that, if x is negative 1, what's negative 2 times negative 1? Positive 2, right? There we go. So we got negative 1, positive 2. If x is positive 2, y has to be negative 4. Perfect. So we do indeed get that line that goes down as we go across the graph. So what we're seeing here is that there's only two things that we can do to that line. We can add or subtract that line. This moves the equation, moves the line up or down on that y-axis. It moves it up or down from the origin is really what it's doing. But we can count, the origin is at 0 here. We can count down or up on that y-axis to figure out where we're going to start the line. So that really changes the starting point of the line. The official name for that is called the y-intercept. It's where it intercepts or intersects the y-axis. And then we have this number here that multiplies our variable, that changes the angle. And the official name for that is the slope. So if I were going to graph this particular equation right here, the negative 3, the minus 3 there tells me that I start from the center of the graph, I go down 3, and that's where I start. So that is my y-intercept at negative 3 on the y-axis, or down 3 from the center. And then the 2 tells me that I'm a little bit steeper than normal. So I look like that. So our next step is to explore that slope a little bit more. Slope is defined in a lot of applications and defined the same way as being rise over run. Now we look at that has a slope of 2. It doesn't look like a fraction. Well, 2 has to be rewritten as a fraction by making it 2 over 1. So what that is saying is we rise 2 units for every 1 unit that we run. So if I go over here to my starting point, that would say I have to go up 2 and then over 1. And there's a second point on the line. And I can keep repeating that. Go up 2 over 1. There's another point on the line. And I can use that to graph my lines. So let's say I have y equals 2/3 x plus 1. What that is telling me to do is I am starting at positive 1 here. So I go up here to positive 1. That's my starting point. Then my slope, the number multiplying the x, is 2/3. That's telling me I'm going to rise 2. So from this point, I go up 2 and run 3. So I go over 1, 2, 3. There's a second point on that graph, so my line goes through those 2 points. So if I have an equation of y equals 3/4 x minus 2, where would I start this one? Well, the number that's added or subtracted is where I start. So that's minus 2. So from the origin, I start out at negative 2, right there. From that point, where do I go? How far do I rise? Perfect. My slope is the number multiplying x is the 3/4. And exactly like you said, we rise 3, 1, 2, 3, and then we run 4. 1, 2, 3, 4. There's my second point. So my line goes through those 2 points. If I have y equals negative 1/2 x plus 3, where's my starting point? 3, very good. The number that's added or subtracted is my starting point. From there, I rise how much? Okay, I'm going to rise 1 and run 2, but I have to see that it's a negative 1/2. So my rise actually goes down 1. Perfect. And then I run 2. Good job. So if we have y equals 3 minus 2x, where does this graph start? X is being multiplied by negative 2. So the 3 is added to it. It's a positive 3. So we start out at positive 3. From there, what's our slope? Perfect. Negative 2 is our slope. We make it negative 2 over 1, so you're absolutely correct. We go down 2, then we go over 1. There's our second point right there. We make our line through it. Now, if we're not sure, if we want to be more careful, we can go with our slope again, down 2, over 1. And we can keep going if we want to, down 2, over 1. We can go right down the graph to make that easier. Now, for your homework, if you want to sketch them out like I'm doing here, that's just fine. I did place in Blackboard for you. It's in amongst the recordings and the course information. There's a blank graphs worksheet here you can open. And that'll actually give you blank graphs that you can use for your homework if you want to as well. Since I'm out here, by the way, also in the course information on Blackboard, you'll notice there's an alternative test 3. The scores for test 3 were a little bit low, so I put this out there. If you would like to download this and work on it, you can discuss it with your friends, work on it with help, or whatever you want to do, and have your contact person at your school return it into them and have them send it to me. I will give you additional points back on test 3. It's pretty common because it's a different way of thinking with the dosage calculations to have groups that have scores that are a little bit lower than we'd like to see on that test. So that's a chance for you to earn some of those points back. Okay, so yeah, go ahead.
Can we fix our test and turn them back in for half credit?
Yes, you can still do corrections on those tests and turn them back in for half your points. And then you can do that. That alternative test is actually in addition to that. You can do that for more points back as well.
Would that be just an alternative to the test, or would it be extra points, like extra credit?
It would be extra credit points on top. So I would recommend you do both, that you do your corrections on the regular test and you do the alternative, and you can get extra points for doing both.
Okay, thank you.
You bet. So not only can we have these equations that don't line up or not set up the way we're used to seeing them, but we might run into one like this. 2y equals 3x plus 4. Here we see that y is not by itself. So we have to get y by itself. And to do that, we have to divide by 2. Since it's being multiplied by 2, we have to divide by 2. When we multiply or divide an equation, we have to multiply or divide every digit in that equation. So here we divide out the 2, so that leaves us with y. Here the 3x has to be divided by 2. Now since that doesn't divide out to a whole number, we treat our division like a fraction. 3x divided by 2 is just going to be 3 over 2 divided by x. We turn the division of the numbers into a fraction. Then we also have to divide the 4 divided by 2 is positive 2. So now that starts out at positive 2, and it goes up 3 over 2. Similar to that, but slightly different, y plus 3 equals 1/2 x plus 1. Here, x is not by, or y is not by itself, so we have to get it by itself. This time the 3 is added to the y, so how do we get rid of it? We subtract 3. When we add or subtract to an equation, we only have to add or subtract to one piece on each side. So we subtract 3 here, and that 3 is gone. On the other side, I cannot subtract 3 from 1/2 x. I can only subtract it from the 1. So the 1/2 x doesn't change. 1 minus 3 becomes negative 2. So that starts at negative 2 and then goes up 1 over 2. And of course, they can get more difficult yet. We can have 3y minus 1 equals, let's see here, 2 minus x. And we have to solve that for y. Y has been multiplied by 3, and then 1 has been subtracted from it. So we have to reverse that. We're going to add 1. When we add or subtract, we only have to do it to one piece on each side. So adding 1 takes care of the minus 1 here. Gives me 3y. We're going to add the 1 to the 2 on the right side. So 2 plus 1 is 3. The negative x doesn't change. Then we have to divide by 3. When we multiply or divide, we have to do it to every digit on both sides. So we divide out, the 3 divides out, leaving us with y. 3 divided by 3 is 1. We can think of this as a negative 1x divided by 3. So it's a negative 1/3 times x. Graphing that, where do we start?
1.
We start out at 1, at positive 1. And from there we go. Perfect. Down 1 over 3. So we have to solve for y to get y by itself. Where it can be even more confusing is if we have the x over there. So we might have 3x plus 2y equals 6. We have to get y by itself, which means we have to get rid of everything else. Y has been multiplied by 2, and then 3x has been added to it. Even though there is an x over here with the 3, we treat it just the same as we did up here with the negative 1. We just get rid of it. So that's 3x, a positive 3x. We get rid of it by subtracting 3x. That leaves us with 2y here. We have to subtract 3x from the other side. We cannot subtract it from 6. So 6 minus 3x is just 6 minus 3x. Then finally, we have to divide by the 2. Because y has been multiplied by 2. That'll leave us with y. When we multiply or divide, we have to multiply or divide every digit in the whole equation. So 6 divided by 2 is 3. Negative 3x divided by 2 is going to give us negative 3 over 2x. So you just make a fraction out of these numbers. You take the coefficient of x, the number multiplying x, and just divide it by, put it over the 2 to make negative 3 over 2 with the x after it. Okay, we only got a few minutes left here, so I'm going to go ahead and give you the homework here. Our homework in the book on page 215, just 1 through 3 is just looking at equations and identifying points. Page 213 through 217, 1 through 15, you can do the odd there. Page 221 through 222, 1 through 15, the odds there. And page 226, 1 through 15, the odds. We will talk a little bit more about some of the stuff on these pages on Friday. I want to talk more about slope and finding equations and stuff like that. Then we will move on from there to the forms of graphs and stuff like that. But for now, if you work on those, and remember, don't forget to download that alternative form of the test from Blackboard. You can work on that for additional points and do your corrections. And Hurley, if you'd remember to just check with your person there to see if they've sent it or have them resend it if they wouldn't mind.
Okay.
Okay, thank you. You guys have a great day, and we'll see you on Friday. Thank you.